So, I've come to the conclusion that I need to move this cab forwards just a touch more. And I also need to move my motor transmission up some because it's on the firewall. There's not enough clearance to put the valve covers on it. So that's going to create an issue later on. I was trying to use this drive shaft, which is already stretched. I mean, it's got the most. I can't get any more clearance out of this. If I pull it up anymore, it's not going to be in the transmission far enough. And I started thinking about things, and I really didn't want to buy a drive shaft, but you know, I'm building this truck. It's going to be a daily driver. I don't want to be scared to get out on the interstate and do 70 with it. And I started thinking about a number of factors. Drive shafts, according to tube diameter, have a critical rotating mass. Add into that, this shaft is probably 40 years old. It come out of something in the mid 80s, C10 or a G10 or something like that. And it was designed behind a motor that had less than 200 horsepower. And I don't know if it was designed to go behind an overdrive transmission or not, but the gear ratio of the rear end was probably 307. So if it was behind, say, a turbo 350 with the 307 gear, then it would turn at the exact RPM that the engine's turning. And then, you know, in the 80s, the speed limit was 55. So probably the safe range of operation with the margin of error or whatever, 70 mile an hour, and the horsepower rating of 200, 250 max. And I started thinking about it. This engine is going to be close to 400 horsepower. It is a stick, so the shock on the Driveline is going to be more. I have a 4-cylinder 5-speed S10 that wheel hops like mad, which is one reason why I want to 4-link this truck to prevent that from happening. But wheel hop is a violent shaking of the Driveline, so that adds more stress to the drive shaft. Then add on to that this is a 373 geared rear end with positive traction. If it doesn't spin and if it actually grips, that's more of a chance of having a drive shaft failure. I will spin the tires on this truck. I will drive this truck hard. And then you think about it, with an overdrive transmission, it's actually going to be spinning faster than the motor. So it'll be turning more RPMs than the engine will. And therefore, I'm not concerned about moving this motor up. This is the critical thing in my thinking is, when I get done with this truck and I park it somewhere and walk away and turn around and look, which I do, and I look at this vehicle and the wheel is not centered in the wheel opening, I'm not going to be happy. So that is the main priority of mine. This is not centered. It has to be centered, which means the body has to move forward 2 or 3 inches, which can't happen right now because the engine is almost on the firewall. I mean, I could change that. It would require some cutting and welding, which I'm not scared of. But also, I went to Jonathan's yesterday. Jonathan covered my seat. He got my bottom done, but he hasn't finished my back yet. But I wanted to get it in here. Now, when I put the floorboard piece in the other day, and let me grab it, I'll show you. The transmission is actually, the shifter position is a couple inches back further than it was factory. I think I got this in, no, that's second or fourth. So that's going to be the furthest the shifter comes back. It's going to clear the seat all right, but it doesn't really feel comfortable. So if I move the engine up 2 or 3 inches to center, and then move the cab up to center the wheel well 2 or 3 inches, that's going to be right where I need to be. Far as, well, actually, if I move the cab up, it's going to be right exactly where it is now. But if I move the cab up 2 or 3 inches and move the engine transmission up, say 6 inches, which would give me, let's don't say 6, let's say 2 inches. That will give us 2 inches more clearance, maybe an inch. But anyhow, that would put the shifter a little further in the floor, which, I mean, I'm gonna remake this part of the floor pan. I'm gonna remake this piece right here because I only got half of it anyway. So I'm gonna remake this whole piece, and the battery's gonna mount right here. So I need a battery box cover, but it doesn't need to be that big. It only needs to be, you know, part of that size. But anyhow, I mean, I want, like I said, this is going to be a daily, so I want it set up right. So I'm gonna figure out what I got to do. I'm gonna move the motor up. I'm gonna move the cab up. Get everything placed right. That might mess my wheel alignment up on my bed. I mean, I don't know. Maybe I could go 2 inches and it's not going to affect the wheel placement on the. See, I don't have fenders yet, and that's the only problem. I can only go by pictures on the bed part. But anyway, I want everything centered up to where the truck looks like it belongs on this chassis. Then I want the controls to be in a comfortable position to drive. The pedal assemblies, the steering column comes through this hole, and the pedals come, the clutch comes through here, and the brake comes through here. So I probably need to move the motor up a little bit, because when I mocked my pedals up, the brake pedal is hitting the back of the head here. So that's another reason to move the motor up a little bit further than it is now as far as the relation to the cab. So if I move the cab up 3 inches and move the motor up 2 inches, one, it's going to put the stick in a better position, and it's going to give me clearance for my brake pedal. Now, when I was at Jonathan's the other day, I wanted his opinion on my clutch brake assembly. And I thought he might advise me to remake this whole assembly and shorten the brake pedal, the pivot point, and use the same pivot point for both pedals. But his advice to me was, because see, the factory master cylinder bolted these two holes, and then had a link that went through this hole and hooked to this lever on the bottom of the brake pedal. And his advice to me was to just take this assembly and mount it in the truck. Do that first. And then come back and figure out what of this assembly I need to trim off. Then I'll either on the frame or on this mount here, weld a plate to bolt my my clutch master, which, you know, it's got an offset mount, which doesn't matter because I'm gonna make the plate for it, and then my brake master. So they'll bolt to the rear here, and the push rod will go up to the pedal. So I'll make a lever to go on the clutch pedal here to pick up the linkage rod for my clutch master, and then I'll do the same thing. There's already a lever on the brake pedal to catch. That's where it caught the factory link for my master cylinder. So that'll hook up my pedals. And then I'll run, like I said, I'm gonna use my factory steering column, and I'm gonna mount it. This is the factory column mount. It'll go through the floor, and then I'll take and use the S10 steering, the collapsible steering shaft. I'll cut the bottom of the column, put a roller bearing in the bottom of the column between the column and the steering shaft, and then I'll cut the steering shaft to make it a double D, and then it will insert into this collapsible shaft and bolt through with the through bolt, just like the S10 original steering column did. So that will take care of the steering. I've got aluminum radiator and aluminum electric fan shroud mount and electric fan, because there's not going to be enough room on this setup to have a mechanical fan, which I would rather have, but there's just not enough room. And then, like I said, then the key is the placement of the cab on here. Then we'll do the cab mounts, and we'll do the core support mounts and the bed mounts. The bed mounts and the rear cab mounts are really simple. The core support mounts are going to be simple, and these middle cab mounts will probably dictate where I'll probably work my pedal mount somewhere off of the cab mount, but it's all going to work out. And then once I get all that done, I mean, this shaft here helps me with the pinion angle and helps me keep my driveline centered in the frame. But when I get all my final done and get my fenders on and figure out my final ride height, then I can make sure my pinion angles are correct and measure for a new drive shaft. Then I'm probably going to go with a 3.5 or a 4-inch aluminum shaft. Probably try to find a factory shaft and have it shortened. That way, you know, all the LS shafts that I've seen are aluminum, and they're big diameter. This is a factory LS shaft right here, and you see how large a diameter this shaft is. So and it's the same length down the whole shaft. So if I can find one, this is way too long. As a matter of fact, I think I'm gonna try to use this one in my Grand Prix here, because it's gonna take a really long shaft. But I'll see if I can find or source a shaft not quite this long, and that way I can have it shortened and make it work with my truck. I mean, the more I think about it, and the critical speed of a tube diameter and the horsepower and all that, I started thinking about it. I don't want, once I get this truck running, I don't want to have to work on it again. And I definitely don't want to be stuck on the side of the road with a broken drive shaft, and possibly a broken transmission or a broken rear end yoke, or even a possible accident because the drive shaft broke and caused a rollover or some ridiculous situation like that. So that's where I'm at right now. I'm gonna slide this motor forward. I'm gonna slide this cab forward. Try to get my finalized placement on my cab. And that way I can move my transmission cross member forward, so no problem, just drilling a couple more holes. And I think I'll be more happy with it, and I think it'll be better overall. So that's what we're gonna do. We'll move this motor, get the cab right, and continue on. So I appreciate y'all watching. Stay tuned. Later.